Okay, module 29. So we're just going to keep going with our sequences here. So I think it should be pretty straightforward for you guys. A little nice way to kind of end here. The first topic here is identifying arithmetic sequences and finding the common difference. Okay, so they're going to give you some sequences. So for example, in this one that I'm looking at, they give you this and the dot, dot, dot showing that it would continue. And it looks like they give you a 3. Okay, so first of all, we have to decide if it's arithmetic or not. Okay, so remember, if it is arithmetic, it's going to have a constant difference between terms. So you want to figure out what's the rule for getting to the next term. So to get from -2 to -9, I subtract 7. To get from -9 to -16, I subtract 7. And it looks like I'm subtracting 7 every time. So that would seem to indicate that it is arithmetic. And the common difference, D, is -7. Okay. If I look at the next one, -5 to -1, I'd add 4. -1 to 3, I'd add 4. 3 to 7, I'd add 4. Definitely appears to be arithmetic with a constant difference of +4. Okay. 3 to 9, I would add 6. 9 to 27, I would add 18. And that's definitely more than 18. So this is not arithmetic. In fact, that one is geometric. If I looked at it closer, I can say I'm multiplying by 3 every time. Okay, and that's not arithmetic. All right. The next one is finding a specified term. It's weird that they have you do this before they have you actually writing the equations. So we'll go through that too. Of an arithmetic sequence given the first terms. Okay. So yeah, what you want to do is I'm going to kind of go in reverse here a little bit. Okay. Further down the road, you have a topic called writing an explicit rule. For an, let's see, it's getting cut off on my screen here, arithmetic sequence. Okay, so arithmetic sequences are kind of like a line. Like you have y equals mx plus b. B is where you start. M is how much you go up. Okay, we just have to do it a little bit different because when we're talking about a line, that starting value is when x is 0. And we're talking about a sequence, it's when like n is 1. So it's just a little bit different. But a sub n would be that constant difference that we just have been calling d times n minus 1 plus your first term. Okay, so again, you start at the first term and then you go up by d, but you want to start, with the first term, not with like a 0 term. Okay, so for example, in the example that is in this problem right now, they give me 4, 13, 22, 31, and so on. Okay, so I can figure out the two things that I need are that my first term is 4, and that difference between terms, it looks to me like that's 9. I'm going up by 9 every time. Okay, so a sub n would equal 9 times n minus 1 plus 4. All right. I am not sure if they're going to have you simplify that. We'll take a look when we get to that one. But you could distribute the 9. And then minus 9 plus 4 would be minus 5. Okay. You can also get that by looking, like if this is your first term at 4, if you were to work your way backwards, you'd have a negative 5 here. Okay, and that's exactly where that negative 5 is coming from. Okay, so I know we kind of talked, when we did Algebra 2, we kind of talked about working your way back to the 0 term. Okay, this is the same thing. Kind of work your way backwards. Okay, but I think the way that it is presented in ALEKS is this way. Okay, so back up to the one that we're talking about up here. So it says find a specified term of an arithmetic sequence given the first terms. So this one says find the 73rd term if the sequence is 4, 13, 22, 31, so on. Okay, so what we just did down here in the purple is we actually found the rule. Okay, where a sub n is 9 times n minus 1 plus 4. Okay, so that's why I said it's weird. They have you doing this first before they have you writing the rule. So I think it's easier if you write the rule first, okay, and then do this topic. So our 73rd term would be 9 times 73 minus 1 plus 4. So 9 times 72 plus 4. Okay, so you can do 9 times 72. I don't know if they give you a calculator on this or not, but we'd have 9 times 70 is 630. 9 times 2 is 18. So we'd have 648 plus 4. So 652. Okay. All right, our next one. It's going to relate to this one also. All right, so these are all tying together real nice, where we should be able to cruise through them. Finding a specified term, again, of an arithmetic sequence given the common difference and first term. Okay, so same as before, if not easier. They give you the two things that you need to actually make the formula. So you don't even need to figure them out like we did up here. We actually they just give them to us. Okay, so we're supposed to find the 16th term when the difference is 6 and the first term is 2. Okay, so our formula, again, is d times n minus 1 plus the first term. So it's 6 times n minus 1 plus 2. So our 16th term will be 6 times 16 minus 1 plus 2, which is 6 times 15 plus 2. So that's 90 plus 2, which is 92. Okay. All right. The next one. Again, really similar. Finding a specified term of an arithmetic sequence given two terms. Oh, I guess this one's a little trickier. Okay, so in this one, they tell you that the 40th term is 153, and that the 75th term is 258. Okay. So I guess it's a little bit more work. Okay. Let's see here. We can get the constant difference. Okay. So it's kind of like a slope. Okay. So in 35 terms from 40 to 75, we go up 258 minus 153. Okay. So we have 105 divided by 35. There you go. Okay. Which is 3. Okay. So that constant difference is 3. And again, it's just like a slope. Okay. It's just like having the points 40, 153, and 75, 258, and being asked to find the slope between those 2 points. Okay. So now all you need to do, like we actually aren't going to find the formula for this one. We're going to just kind of use that same rate. So we're supposed to find the 12th term. Sorry, I should have said that earlier. 12th term. Okay. So basically, we don't know what the 12th term is, but we know what the 40th term is. Oops, 153. And we know that the distance or the difference is 3. Okay. So we need to just work our way back 28 terms. Okay. So 40 minus 12 is 28. Okay. So we have to subtract that 3 28 times. Okay. So a sub 12 would be the same as a sub 40 minus 3 times 28. Okay. That's how, like you could figure out, well, what's the 39th term? I'd have to subtract 3 to get down to 150. What's the 38th term? 147. What's the 37th term? 144. Keep subtracting 3, right? Well, if I want to work my way all the way back to the 12th term, then I'll subtract it 28 times. Okay. So I'm going to have 153 minus 3 times 28 is 74. Did I just do that right? No, it's not. It's 84. Okay, so 153 minus 84, it gives me my answer of 69 would be the 12th term. Okay. All right, next. The next one is actually writing the rule. Okay, so we already did that one. Okay, so right up here, writing the explicit rule for an arithmetic sequence. And I'll just confirm they do want you to simplify it down
Mason
to here.
Ames and Alice Bissell. Your IDs are at the security desk.
Thank you for the announcement.
Alice Bissell
Okay.
and Mason Ames. Please stop by the
So
security desk.
leaving it like this is fine for when you're just doing work, but when we're reporting the final answer of the rule, they want that. Okay, so just make sure you get it down to there.
Sam Nascari, please report to the office.
All right, our next one is sum of the first n terms of an arithmetic sequence. Okay. So they give it to you 2 ways. Okay. They give it to you like that. And they also give it to you that's a 118. Okay. So it seems like they want you to add all of these together. So in the first one, -5 plus -7 plus negative 9, not so bad, but look at all the blanks you have to fill in to get to negative 155. Okay. And then same thing with part B. That sigma stands for sum. Okay, it's shorthand for sum. Starting with the first term 1, to term 118. Okay, that's a lot to work out. All right, but lucky for you, there is a formula for this. Actually, here's a little bit of history for you. Gauss was the guy who discovered this formula. Okay, to sum terms of an arithmetic sequence, we take however many terms it is times the first term plus the last term over 2. Okay, so definitely a nice easy shortcut for that. So for this one, we would do, oops, come on. Okay, so all we need to do, so the first one, we know that we would have negative 5 plus negative 155 over 2. We just don't know how many terms it is. Okay, so we do need to figure out, well, this constant difference is negative 2. Okay, so to get from negative 5 to negative 155, we would have had to have subtracted 2 how many times? Okay, so this is minus 150. Okay, so that's the difference there between the first term and the last term. And we're going to divide it by negative 2 to get 75. Okay, so we had to subtract 2 75 times, but be careful. Don't forget that we started with the first term. So n is 76. Okay, and I'll do another one like this for you too. All right, but just figure out, we want a total of minus 150 by 2's. So that's 75. And don't forget, that's just how many times we subtracted. So we have to think about where we started to. Don't forget the first term. So you always add 1 to that. So we'll have a 76 here. Okay, so you're going to use a calculator for this. Okay, but it comes out to be negative 6,080. I'm pretty sure they'll let you use a calculator for that. Okay. All right. Actually, the second one is, even though it looks trickier, it's actually easier. Okay. We know it's going to be 118 terms. But the part that they don't give you here is what the first term and the last term are. So we can just plug them in. Okay. So a sub 1 would be 3 times 1 plus 3, which is 6. And a sub 118 is going to be 3 times 118 plus 3, which, use your calculator, that comes out to be, oops, I'm sorry. I got my parentheses in the wrong spot there. 3 times 118 plus 3, that's 357. Okay, and again, you can use your calculator for that, and we get 21,417. Okay, I'll do 2 more for you, just so you get that trick with the first one a little bit better. Okay, so next they give you 6 plus 10 plus 14 plus ... to 462. And then they give you the summation from 1 to 96 of negative 5j minus 4. Okay. So again, for the first one, we're adding 4. Okay. And going a distance of 436. Okay. So how many times did we add 4? Well, whatever 436 divided by 4 is. Okay, so 436 divided by 4 is 109. And then we have to add on that first term to get that we have a total of 110 terms. Okay, so we have, hold on a second. Oh, I did that wrong. 462 minus 6 is not 436, it's 456. Ay, ay, ay. 456 divided by 4 is 114. And then we'll add 1 to that to get 115. Okay, so we'll have 115 times 6 plus 462 over 2, which is 26,910. Okay, and then for part B here, the first term would be negative 5 times 1 minus 4, which is negative 9. And then our last term would be negative 5 times 96 minus 4, which is negative 484. So the sum of our 96 terms, 96 times negative 9 plus negative 484 over 2. Okay, and that works out to be negative 23,664. All right, let's take a look at our next one. Looks like we're going to do some geometric sequences now. So finding the next terms of a geometric sequence with signed numbers. That just means that we'll have some positive and some negative. Okay, so geometric, remember you have a constant multiplier. Okay, so we would have, they have 4, negative 8, 16, and they want us to find the next two terms. So just figure out what your multiplier is. We're multiplying by negative 2. Okay, so our next term would be 16 times negative 2, which would be negative 32. And then multiply that by negative 2 and we get positive 64. That's it. That's all you got to do. Okay. Oh, and I think it said next 3. So the next one would be negative 128. Okay. Next one kind of ties in with one that we already did. Identifying arithmetic and geometric sequences. So we did identifying arithmetic. Now we're just throwing in geometric too. Okay, and we even in the example that we did for the arithmetic when we talked about how it's geometric. Okay, so they're going to give you some sequences. You determine if it's arithmetic, geometric, or neither, and that's it. Okay, so 16, 4, 1, 4, 128, 32, 8, 2, and 15, 18, 21, 24. Okay, and so you just figure out if there is a constant difference between terms, a constant multiplier between terms, or neither. Okay, so for the first one, we can say, well, if it was arithmetic, this would be minus 12, and that's already not minus 12, so it's not arithmetic. Okay, if it was geometric, let's say I'd be multiplying by 1/4. Okay, and then times 1/4, that's working. Oh, but 1/4 times 1 is not 1. 1 times 1/4 is not 4. Okay, so it's neither. Okay, there's no constant difference or constant ratio. All right, for the next one, I can already tell I'm not adding the same thing, right? To get, I'm not even going to worry about the big numbers there, but to get from 32 to 8, I would subtract 24 to get from 8 to 2. I would subtract 6. It's not arithmetic, okay? To get from 32 to 8, I would divide by 4, which is the same as multiplying by 1/4. 8 to 2 is also multiplying by 1/4. And then 128 to 132, that's also multiplying by 1/4. Okay, so I can figure out that is geometric. Okay, and then here, the last one, add 3, add 3, add 3, that's arithmetic. Okay. All right. Next one, you are going to identify, it's very similar. You're identifying geometric, and if it is geometric, you're giving the multiplier. Okay, so identify geometric sequences and finding common ratio. Okay, so here we've got 4, 12, 36, 108. And then we've got 4, 8, 12, 16. And then we have 500, negative 100, 20, negative 4. Okay, so 4 to 12 is times 3. 12 to 36 is times 3. 36 to 108 is times 3. So it is geometric with r equal to 3. Okay. 4 to 8 is times 2. 8 to 12 is not times 2. So it is not geometric. And in fact, we could see that's arithmetic, right? We would add 4 every time. Okay. 500 and negative 100. That is times negative 1/5. Okay. 100 is 1/5 of 500. Negative 100 to 20 is also times negative 1/5. 20 to negative 4 is also times negative 1/5. Okay, so we do have geometric here, and the r is negative 1/5. Be real careful, because we know we're technically also dividing by negative 5, which is a good way to tell that it's geometric, but your multiplier needs to be 1/5. We can't talk about like the constant divider. Okay, we have to, what do we multiply by to move forward? Okay. All right. Next, we have finding a specified term of a geometric sequence given the first terms. Okay, and I looked, and they don't have you write equations or write explicit rules for geometric sequences. Okay, so I'm going to show you though. Okay, because just like with the arithmetic ones, it's easier if you have it. So a sub n is a sub 1 times that constant ratio to the n minus 1. Okay, so in the example that we have here, we're told that it's geometric and it's 5, 15, 45, 135, and so on. Okay, we are multiplying by 3. Okay, so the first term is 5, and the ratio is 3. So our formula would be 5 times 3 to the n minus 1. Okay, if you were to simplify that, we would use your rules of exponents. That's 5 times 3 to the n times 3 to the negative 1. So that's 5 times 3 to the n times 1/3. That'd be 5/3 times 3 to the n. Okay, and just like before with the arithmetic, you could get that by working your way back to the 0 term. Divide by 3. Okay, but they're just having you use the relationship here. So we're supposed to find, with this geometric series, find the 13th term. So the 13th term would be 5 times 3 to the 13 minus 1, which is 5 times 3 to the 12th. Okay, that's going to be a big number. A really big number, actually. 3 to the 12th times 5 is 2,657,205. Okay. All right, our next one. We have finding a specified term of a geometric sequence given the common ratio and ratio and the first term. Okay, so we can again just use our relationship there, okay, that I just wrote up there for you too. Okay, so in this one, they want you to find the 6th term, where the ratio is 2/3 and the first term is 4. Okay, so our formula would be this. And so when we're finding the 6th term, we'd have 4 times 2/3 to the 6 minus 1, which is 5. Okay. They want you to leave this as a fraction. So we're going to do 4 times 2 to the 5th over 3 to the 5th. So that's going to be 4 times 2 to the 5th, which is 32. And 3 to the 5th, which is 243. So it's going to be 128 over 243. All right, we are cruising here. Next one. We have finding a specified term of a geometric sequence given 2 terms of the sequence. So again, another one that we did similarly with arithmetic. Okay, so in this one, they tell you that the 10th term is 19 over 16. The 13th term is 76. We want to find the 15th term. Okay, so we can figure out to get from 10 to 13, we had to multiply by that ratio 3 times. Okay. Okay, just like with addition, we figured out how many times we had to add it. Now we figure out, well, to get from 10 to 13, that's 3 steps. So it had to multiply 13 times. Okay, so that would mean that r cubed is the 13th term over the 10th term, which is 76 over 19 over 16. Okay, and I'm going to assume they're going to let you use your calculator for this, but that comes out to be 64. Okay, so they're going to give you some nice numbers here at least, but There you go. So if r cubed is 64, r is the cube root of 64, okay, which is 4. All right. So you can figure out to get to the 15th term, we'd have to take the 13th term and multiply it by r twice, okay, to get from 13 to 15. So it would be 76 times 4 squared, 76 times 16, which is 1,216. Okay, I'll do another one of those just in case you need it. So the next one we have the 8th term is 31 over 125. The 12th term is 155, and we're supposed to find the 16th term. Okay, so again, this is a jump of 4, and this is also a jump of 4. Okay, so a sub 8 times r to the 4th should equal a sub 12. So r to the 4th would be the 12th term over the 8th term, which is 155 over 31 over 125. So 155 over 31 over 125 is 625. Okay, so r is the 4th root of 625, which is 5. All right. So we can then do that the 16th term would be the 12th term times r to the 4th. So that would be 155 times 5 to the 4th, 155 times 625, and we get 96,875. Okay. Now, we could have done a little bit of a shortcut here when we figured out that to get from here to here was times 625. We could have also just done it here. Since the step size was the same, the multiplier would be the same between them. Okay. All right. Next one we have arithmetic and geometric. Sequences. Identifying. Oh, now they have you writing the one for geometric too. Okay. So we've already done this individually for both. Now they just kind of combine it. Okay. So for your arithmetic, a sub n is the first term plus n minus 1 times the difference. And then you're going to want to simplify it. Okay. And then for geometric, a sub n is a sub 1 times r to the n minus 1. And I did show you earlier on how to simplify that. It looks like they're taking it with just leaving it as the n minus 1, which makes it a little easier for you too. Okay, so they give you two sequences here. We have 18, 25, 32. And then we have 7, 28, 112. Okay, so first thing that you have to do is figure out if it's arithmetic or geometric. Here, we'd add 7, right? So this is arithmetic. The first term is 18. The difference is 7. So a sub n will be 18 plus n minus 1 times 7. We do need to simplify this one. So 18 plus 7n minus 7. So it's going to be 7n plus 11. Okay. Here we're multiplying by 4. So it's geometric. The first term is 7, and the ratio is 4. So a sub n is the first term times 4 to the n minus 1. Okay. All right, next one. We're almost done here. We want to do the sum of the first n terms of a geometric series. Okay. Just like with arithmetic, there's a rule for this. It is the first term times 1 minus r to the n over 1 minus r. Okay. So in this example, they have us doing 4 plus 4 times 3 plus 4 times 3 squared plus 4 times 3 to the 5th. And then they have us do some -1/2 to the I. Okay, so that first one, okay, we need to figure out what a sub 1, r, and n are. Okay, so our first term is 4. You can tell that. We can see that we're multiplying by 3 every time. Okay, and this one kind of makes it easy because you can tell we've multiplied by 3 5 times then. Okay, so let me just make sure I'm not, oh, hold on. Oh, and I knew that was too easy. Okay, we've multiplied by 3 5 times, but again, don't forget that first term. Okay, so the first term, the second term, the third term. Okay, then we'd have, this would be the 6th term. Okay, so n is 6. All right, so the sum of the first 6 terms will be the first term, 1 minus 3 to the 6th over 1 minus 3. Okay, and you can use your calculator for this. So we would have, let's see, 3 to the 6th is 729. And then that would be -2. Okay, so we'd have 4 times 1 minus 729, which will be -728 over -2. So the 2's will cancel out, and we get 1,456. Okay. For our next one, the first term, if I were to plug a 1 in, I would have -1/2. Okay, the ratio between terms is -1/2. And I have 8 terms. Okay, so I would find this sum by doing -1/2, 1 minus -1/2 to the 8th over 1 minus -1/2. Be really careful with all those negatives. Okay, so we'd have -1/2, 1 minus And negative 0.5 to the 8 should be positive. So be really careful. In your calculator, you have to put it in parentheses. In parentheses, negative 1/2, and then take it to the 8th power. Okay? Or just do 2 to the 8th. Okay, here, let me. Negative 1/2 to the 8th power will be 1 to the 8th over 2 to the 8th. Okay, and it will be positive because of the even power. So we'll have 1 over 1 over 2 to the 8th is 256. And then we have a double negative in the denominator, so that'd be 1 plus 1/2. Okay. So the next thing we can do then is it'd be negative 1/2. 1 minus 256, so that'd be 256 over 256 minus 1 over 256. So we'd have 255 over 256 over 2 over 2 plus 1 over 2, which is 3 over 2. Okay. Take your time and make sure we're doing this carefully. I'd have negative 1/2 times 255 over 256 divided by 3/2, so times 2/3. So these 2's will cancel out. 255 divided by 3 is reducible. This is 85. So I'll have negative 85 over 256. Okay, I will definitely do another one of those for you. So the next one we have is 5 plus 5 times negative 1/4 plus 5 times negative 1/4 squared plus 5 times negative 1/4 to the 4. And then they give you the sum I equals 1 to 9 of 3 to the I. Okay. Up here, your first term is 5. We're multiplying by negative 1/4. And we can see this is your first term, this is your second term, this is your third term, this would be your fifth term. So n is 5. Okay, so again, using our formula, we would have the sum is the first term, 1 minus the ratio to the nth over 1 minus the ratio. Okay. So again, we'll have 5 times 1. Now, when I take that negative 1/4 to the 5th power, it's going to be negative. Okay, so I'll have minus a negative. Okay, so this one is going to be plus 1 to the 5th over 4 to the 5th over 1 plus 1/4. Okay, so I'm going to have 5. 4 to the 5th is 1,024. Okay, so I'm going to have 1,024 over 1,024 plus 1 over 1,024 over 4 over 4 plus 1 over 4. So I'm going to have 5 times 1,025 over 1,024 divided by 5 over 4. So I will have 5 1,025 over 1,024 times 4/5. Okay, and again, you're going to be able to, you'll see that you can reduce these. The 5's cancel out. 1,024 divided by 4 is 256. So I have 1,025 over 256. Okay. For the second one here, the first term would be 3. The ratio between terms is also 3, and I have 9 terms. Okay. So I would again have the sum would be the first term, 1 minus the ratio to the 9th over 1 minus the ratio. Okay. So 3 times, let's see, 3 to the 9th is 19,683. So I'll have 3 times negative 19,682 over negative 2. Okay, and just use your calculator. The negatives cancel out, and we end up with 29,523. Okay, one more topic in this module, which is actually easier. It might sound really confusing, but it is the sum of an infinite geometric series. So we just figured out the sum of a certain number of terms, and it might make your brain hurt, but we can actually add up all the terms in an infinite geometric series. Okay, so for this one, the sum is just the first term over 1 minus the ratio. Okay, it's that easy. So it's a little bit easier than what we just did. So this one, they give us 2 examples. We have negative 2 plus negative 2 squared plus negative 2 cubed, and so on. And then we have the summation from 1 to infinity of negative 2/3 to the I. All right, so in our first example here, the first term is negative 2, and the ratio between terms is actually also negative 2. Okay, now here's the thing. This only works if the ratio between the two terms is less than 1. And it has to be the absolute value. Oops. If and only if the absolute value of r is less than 1. Okay. Otherwise, it just goes to positive or negative infinity, basically. Okay. So the absolute value of r here is 2. Okay, which means there is no sum. We can't add these up. Okay. But this guy here, if I plug in 1 for I, the first term is negative 2/3. The ratio between terms is also negative 2/3. And the absolute value of that is 2/3, which is less than 1. So I can find the sum. Okay. So remember, the sum is the first term over 1 minus the ratio. So it's negative 2/3 over 1 minus negative 2/3. So 2/3 over 1 plus 2/3, which would be 2/3 over 3/3 plus 2/3, which is 5/3. So 2/3 times 3/5, and your answer is 2/5. Okay. Oops, and I lost my negative. Negative, 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 negative. Okay. And that's it. And that is it for this module then also.